Hello everyone! Now we are here to present our second project in Intermediate Thermodynamics about Ramjet and Scramjet engine. This presentation is arranged by Dara Ginanti, Desinta Dewi Ramadhani, and Putri Angelica. And here are the overview of today's presentation. The first section is introduction about the Ramjet and Scramjet engine. The second section is about simulation and result using MATLAB to simulate the nozzle. And the third part is comparing the result from MATLAB with our manual calculation. And now let us just jump to the first section. A ramjet and scramjet are both types of jet engine. Ramjet engine provide a simple, light propulsion system for high-speed flight. A scramjet engine is an improvement over the ramjet engine as it efficiently operates at hypersonic speed and allows supersonic combustion. The supersonic combustion in ramjet and scramjet provide high thrust and low weight for hypersonic flight speed. And this is the working principle and the nozzle. Unlike a turbojet engine, ramjet and scramjet have no moving part. It only consists of an inlet, a combustor that consists of a fuel injector and a flame holder, and a converging diverging nozzle. When mounted on a high-speed aircraft, large amounts of the air from the surrounding are continuously brought into the engine inlet because of the forward motion of the aircraft, and then the air is slowing going through the inlet, and the dynamic pressure due to the velocity is converted into higher static pressure. At the exit of the inlet, the air is at a much higher pressure than the free stream, while the free stream velocity may be either subsonic or supersonic. Because the exit velocity is greater than the free stream velocity, thrust is created as described by the general thrust equation. And here are how the nozzle used to accelerate the flow. The flow existing at the inlet of ramjet is always subsonic, while the flow of a scramjet is supersonic and has fewer shock losses than a ramjet inlet at the same vehicle velocity. In the burner, a small amount of fuel is combined with the air and ignited. Most of the hot exhaust has come from the surrounding air, and flame holder in the burner localize the combustion process. And leaving the burner, the hot exhaust passes through the nozzle, which it will accelerate the flow. And now we also have the advantage and limitation. The first advantage is that this machine has a great power to weight ratio compared to the other machine, and it also has a smaller engines compared to other machine considering the power developed. And the third one is a simple and light propulsion system for high speed flight. And we also have the three limitation here. The first one is not efficient at relatively low speed, and it also have high instrumentation cost and cannot produce thrust from a standstill. And then let us move to the second part, which will be explained by Desinta, time issues.
Okay, thank you, Dara. In this part, I will explain about our results of playing with the MATLAB tool. First of all, here is the expected result for each cases. We need to find for case A, B, D, E, J, and I. The area ratio that we are using is 1.34 we get from this reference. Then after performing the MATLAB simulation, here's the result for each case, and this is the list of the value of PB over PC for each case. After we found this value, we will analyze what will happen if the area ratio is being decreased and increased. Let us go first on case A. In case A, there is no flow flowing through the nozzle, and as we change the area ratio, the Mach number and P over PC value will stay constant. In case B, at area ratio less than 2.16, the flow is subsonic flow. Otherwise, the shock will occur on the nozzle. For this case, at this area ratio range, the maximum Mach number is on the throat, and at this range of area ratio, the maximum Mach number is not on the throat but on the location directly after the throat. Next, this is the case D. When the area ratio is increased, there are some critical points where the value of Mach abruptly decreases after going increased for a while on value of area ratio equal to 9.7. For the rest values, the Mach will keep getting increased as the ratio are also increased. There are some points where the Mach become constant or decrease a bit also. When the ratio of area is decreased, it will result on lower Mach number and different graphs. Case E has similar property with the previous case, case D. The only difference is that the abrupt change happened on ratio of area equal to 8.9. So here is case G. In original condition, the shock happened at x equal to 10. When the area ratio is decreased from x equal to 0 to x equal to 1.34, the shape is the same. There is only a slight difference in the terms of geometries. What interesting in this case is when the ratio of area increases to 1.35, the shock will be in horizontal position. And the last one is case I. In the original area ratio of 1.34, the shock line is in horizontal. Once we decrease the area ratio, the shock starting line starting to steep and create gradient. And as we decrease the area ratio, the gradient got steeper. The gradient moves in the opposite direction when the ratio is increased, then goes straight again while it reaches the maximum ratio. So here's the end of part 2. Next part 3 will be explained by Putri. Putri, time is yours.
Okay, so this is the case E, the plot of the case E, and we are interested in obtaining the values of mx, p over po, and a over a asterisk. From the plot, we can see that mx is equal to this 1.412. The value of p over po is this 0.3089, and the value of a over a asterisk is this 1.126. We calculate the value of P over PO using equation 9.55, and we get that the value of P over PO is 0.3090, which is close with the one that we have from MATLAB. And then the next one is calculating A over A asterisk using equation 9.52, and we get that the result is equal to 1.1216, which has a bit difference in the value that we obtain from the MATLAB. The next one is we interested in analyzing the value of my from three different methods. The first one is from the plot. You can see from the plot that the value of my is equal to this 0.7286. While using equation 9.55, we get that the value of my is 0.7347, and using the interpolation on by table 9.3, we get that the value of my is 0.7351. And if we compare the interpolation method and the equation 9.55 is actually close, but those two are a bit different with the one that we have from the MATLAB. So the next one is determine the value of py over px. So the first one is from the plot. So in the plot, we cannot get directly the value of py over px, so we need to divide the value of py over pc with the px over pc, and then we get that the value of py over px is actually equal to 2.1674. Using equation 9.54, we get that py over px is 2.1749, and using interpolation, we get that the value of py over px is 2.1606. So if we compare, the value of interpolation and the value from the plot is actually close, while the value from the equation 9.54 is a bit different with the value of these two. It is a bit far from value of these two methods.
Okay, this is the last section in today's presentation, which is the conclusion. And from the three sections that have been explained, we come to a conclusion that an application of converging diverging nozzle is in Ramjet and Scramjet. It provides a simple propulsion system for high-speed flight and has a great power to weight ratio compared to other machines. Unfortunately, this machine does not work efficiently in a low Mach number under 0.5 and in a condition of slow speed below 100 knots. By using the MATLAB simulation, we analyzed the converging diverging nozzle and found P per PC value for case A to I. Generally, when the ratio area is increased, the Mach number will also be increased. Opposite, P per PC value will be decreased. And this work also evaluate three methods to analyze the parameters. The first one is using the MATLAB simulation, and the other two is by manual calculation and table interpolation. The three results shows a similar values and there is no significant difference among them.